And lastly, in this installment, we are going to come full circle and revisit Kepler's third law. And if we were to define it, it is simply to state that for a central body, the ratio of the period squared to the mean orbital radius cubed is constant for all of its satellites. So that's for a central body, the ratio of period squared to the average, the mean radius cubed, is a constant. And again, the derivation we had for this came from Newton's second law, where F net is the sum of the forces, and the net force is ma, and that force that's causing that centripetal acceleration is gravity, and the centripetal acceleration is mv squared over r, and the force of gravity is big G, big M, little m over r squared. And what we said previously was that when we have an object in an orbit like the sun and the Earth, in this particular case, when we're comparing the force of gravity, little m is the Earth. And when we're talking about an object that is being accelerated, changing from its deviated linear path, it is the Earth again, so these m's cancel. And v squared over r, we showed previously, was 4 pi squared r over t squared. Putting the numerical constants together gives us 4 pi squared. And numerical constants are those that do not change for the central body. So 4 doesn't change, doesn't matter where we are. Pi is not going to change. The r will change if we're now looking at Mars. So that will go to the other side. Becomes r cubed. And t squared will change. The period will change with different planets. So t squared goes on top, and that leaves us with gm on the bottom. And since 4 is constant, pi is constant, this is constant everywhere in the universe, and the mass of the sun is constant, that is Kepler's third law, which we see as this, but the constant is 4 pi squared divided by g over m. And so the only thing that if we were to now, say, go to another star system or to a planet or something like that, the only thing that could possibly change would be the mass of the central body. So this changes when we move to a new system. This Kepler's third law, we are going to verify that is one of our upcoming labs. Maybe by the time you get to this lesson, you will have already started it. But in any case, that's what we are doing with Kepler's third law. That's Kepler's third law.